Alright, today Academic Daddy will be teaching you physics. This is vectors, scalars, addition of vectors, triangular method, everything that we'll be teaching you today. Alright, so let's start with uh, scalars and vectors. Now, when you talk about scalars, know that what we are talking about is just magnitude. That is why we normally say that ye ones are scalar quantities. They have magnitude but no direction. You tell them, oh yeah, there you go. So now for vectors, when you talk about magnitude and direction. Now, if I have scalar, it simply means that magnitude, it has value. Let's say 2, let's say 4. It must be in the same unit. Let's say 4 seconds, 2 seconds. It cannot be 2 hours and 4 seconds. Then you, in that case, you have to, if they tell you to add this, you have to convert to the same unit before adding. Now, when it has to do with vectors, if you see any number, it's supposed to carry an arrow to show you the direction. If it's not carrying this, you will see it will have this, and it will have something like I, or maybe J, or maybe K. This is what we call unit vectors. Unit vectors, to show you the direction, to show you that I means x-axis, J means y-axis, and K means z-axis. So to show you the direction that is going. So to show you the direction. So this is 3 component vectors. A situation where you have just I and J, or a question is given to you and they write maybe to find something like this. Automatically take this to be x, take this to be y, which means that this is talking about x-axis and y-axis, which means you can write this, So once you know this, you understand what vectors is all about. Now the next thing is what we call addition and subtraction of vectors. Addition and subtraction of vectors. Addition and subtraction of vectors. Now, when you think of addition and subtraction of vectors, we have 2 methods. We have what we call the triangular method of addition, and we have what we call the parallelogram law of vector addition. Parallelogram law of vector addition. Now, when we are talking about triangular law, we are talking about head and tail. And when we are talking about parallelogram law, we are talking about tail and tail. So if, for example, I'm given to add 2i plus 2i, it simply means that I have 4i, Shibi. Now, if for example, I want to now apply this approach, it means that this will have head this way, this will have head this way. Notice that it's going in the same direction. Its direction, x-axis. So if I'm adding this now, I'll just have this to be this way, and notice that this one is this way as well. It's coming to the head. So you notice that for us to have this triangular method at work, it has to be when one is on this component and the other one is on this component, so that if I want to get this now, I'll have a situation where I have, let's say, one is this way and the other one is this way. I'm told that this is 2 and I'm told that this is 4. For me to now add this up, the resultant will be when I come and say, when I get this to become in such a way that the 4 comes here, then I come and attach the tail of the 2, the direction, to this going up. So for me to find the resultant is simply when I now join this. Notice that the resultant now will be the head of the resultant will meet the head of the second vector, so that this will now be this way. This is now the resultant of 4 plus 2. You understand? That is how you do addition using triangular method. A situation whereby I am asked to get 4 and minus 2. The law states that if I want to get this 4 minus 2, ask yourself what direction is the 4 going. Let's say I'm giving this to be in I. So let's say I'm giving this to be in this direction, and I'm giving this particular one to be in this direction. That means that if this is minus and this is positive, this can also be the same thing as saying 4 plus minus 2. So that means that the 2 of this was going in this direction. The positive 2 is supposed to be in this direction, while the negative 1 is supposed to be in this direction. So using this approach, it simply means get what I have here for 4, carry this thing that I have for minus 2 and put here. The tail, I told you it's head and tail. So the first one, get it and put here. So that whatever for the last part, that is the resultant will always be head of the first vector given to you, tail of the first vector and the tail of the resultant, then head of the second vector and head of the resultant. So when I join this is my resultant. So this is that 4 minus 2. So this will now give me 2. So this is for triangle method. And what does triangular method say? Triangular method states that two vectors can be found using the two sides of a triangle. It says that two vectors A and B can be found using the two sides of a triangle. Using the two sides of a triangle. Two vectors A and B. A and B can be found. Now notice something. This is wrong. It's not like this. Two vectors A and B can be found using the two sides of a triangle. Now notice that if this is this way, it means that this is the head of this. Head and tail. And assuming this was to be this way, maybe going up, it will now have it that this will be the head and this will be the tail, and this is head. Are you understanding it? Head and tail. So that means that you need to know that this is called, the arrowhead is called head. Then the down part is called the tail, or you call it terminus. So if that be the case, now it says two vectors A and B can be found using the two sides of a triangle, and the resultant placed in opposite direction. The resultant placed in opposite direction. So that means that if I am to get the resultant of this, notice that everything here, when I place the resultant now, it will be in such a way that the resultant will be in such a way that since this is going towards this way, normally somebody will expect that I will come and place this arrow here so that it will be movement this way and this way. No, but it says that the resultant can be gotten by placing it in the opposite direction, so that this becomes A plus B. So for this one now, notice that this is going this way. If I have the resultant this way, somebody will expect that for the fact that this is going, this one is this way, this one is this way, and this one, that I should come and place it so that it will be rotating. If it rotates, that means it's no longer a resultant, it's equal to them. So the resultant can be gotten by placing it in the opposite direction. So this is the A plus B. So that's, just notice that it's opposite direction. Notice that this one is going this way, this one is going this way, opposite. So if I know this is for triangular method. Now let's move to parallelogram method. Now parallelogram law states that when you have two forces that the resultant can be gotten, let's say I have the two forces this way now. I have these two forces now. Let's say A and B, or let's use X and Y. Let's use X and Y. Now, it's saying that a situation where I have the head and I have the head this way, that this tells that by the time I join it, that is the tail of y and the tail of x should join, that this particular resultant, that the tail of the resultant should come and join it as well. So that by the time I now trace a diagonal to be equal to x and another diagonal to be equal to y, that this particular diagonal line, sorry, I say diagonal, a parallel line, by the time I have a parallel line and a parallel line to come and meet this, that this diagonal I have here is my resultant. So that means that if I have a force, let's say 5 Newton, and I have another one, 5 Newton going upwards, or let's say at an angle, then I have 4 Newton going horizontally. Parallelogram law is saying that I should bring the 5 Newton that is going at an angle, then bring my 4 Newton in such a way. Notice that if it's triangular law, I'll come and carry this tail and put on the head, or carry this tail and put here. But in parallelogram law, it's saying that you should bring the tails and join. And that when you join it, that this is now your 5 Newton, this is now your 4 Newton. That by the time you trace a diagonal, or by the time you make this particular line to have a parallel line, lines that can never meet up, and this one have a parallel line that can never meet, that the diagonal traced here will give you the resultant. So that the diagonal here is the same thing as your 5 plus 4. This is what parallelogram law is saying. So that means that any situation where you have a situation like this, and you're having this kind of right angled triangle, this is called perpendicular, this is called parallel. Any situation where you have this, by the time you trace this and you trace this, what you have here gives you the resultant. And notice that what you have here is now this thing that I have here is the same thing as when you have this way. And notice that the two always fall back to give you the same answer. The two always fall back. Whether you use triangular method or parallelogram method, is the same. What you have will always give you the same answer. But it's just that there are cases you need to know. Whenever an angle is given to you and that angle is less than 90, it's advisable that you use this parallelogram law. Now, and it's from this parallelogram law we get the cosine rule. There's something called cosine rule. Now, let's take it that I have this. Let's say I have this now. Okay, let me draw another one. I have this, and I have this now, and I have F1, and I have here to be F2. Here is X. Vertical is always Y. Notice that if I have this to A, B, C, and D, that this F1 is the same thing as this F. But let me use the dotted line so you know it. Now, do you know that for the fact that this is this way, if I notice there's an angle I see here, let's say I call this O. So to get the rule, it says that the resultant here can be said to be R squared equals to this F1 square, then F2 square. Now notice that this is also here, 2 forces, 2F1, 2F2. So minus 2F1 F2 cos 180 minus theta. And you know that by trigonometry, 180 minus theta, cos 180 minus theta is equals to minus cos theta. So let's replace it. It now becomes L square is equals to F1 all square plus F2 all square minus 2F1 F2 minus cos theta. So when this and this times, it will change to plus. When what you have here and what you have here times, because you can see that naturally can see that, look now, look here, you see that this is cos. It's supposed to be times this. So when this times this, you now have that it will change to plus. So it's now 2f1 f2 cos theta. So that is how you get that your law that they normally tell you PQ and the rest. So this is your law. So but whenever it's just right angle, whenever the angle is just right angle, maybe what's it called, they give you just right angle, you use r square equals to f1 square plus f2 square. That is Pythagoras rule. Pythagoras cosine rule. Now a question can come now, they ask you, notice that this is now, when we find this theta, this is angle theta, but a question can come when they ask you to find this angle here, the angle between the resultant and each of the forces. Any situation like that, notice that if this is theta here, there is also theta in here at this part where I have this triangle, and if this is f1, there is also f1 here, because this line is parallel to this. There's also f1 here, and if that is the case, that there's also f1 here, that means that for this particular one, this is like the resultant. Now vertical is called x, vertical is called y, y for vertical line. Then this side now, everything here is x-axis. So if I want to do this very well, if I want to get it, notice that this now forms a triangle, something like a right angle triangle here. So if it forms that right angle triangle, it means that this will now give me that for getting this angle, I'll have that, getting this particular angle here, I'll have that this is the same thing as our normal methods of finding Pythagoras. Okay, do you know what will happen? What happened is, in order not to confuse you, let me draw a new triangle. Let's take it that you now understand how to use this particular one to get these formulas. Let's draw a new triangle so that you understand how to find. So notice that from here, let's say I call this DO. Notice that from here, DO is more like X here. So notice that from here, I have everything here to be the center. When I'm finding this angle, for Y is going to be equals to